Okay, so we introduced transformations on Friday, and we talked about translations, which are probably the easiest type of transformation. Today we're going to be talking about reflection. So, really quick, using what we know about words, what do you think reflection means?
So a triangle will be like this on one side and like this on the other side.
Yeah, so a mirror. When you look into a mirror, what are you actually seeing? Your reflection. So a reflection is going to be the mirror image of the original image or the pre-image. So a reflection is a transformation that is the mirror image across a given line. Okay, so in our example with the triangle, if I have a triangle that looks like this, and let's say I reflect it about that line, the mirror image would look like that. So we can reflect across any line that we want, and that is called the line of reflection. So the line of reflection is the given line to reflect across. So in the example that I gave you guys already that looked like this, your line of reflection is that dotted line. Okay, so that's your line of reflection. Okay, so when we're talking about reflections, there's a few properties that we need to be aware of. A reflection across a line M is a transformation with the following properties. If a point A is on line M, then the image of A is that of itself. So in the little picture that I gave you guys, notice how the point A is right on that dotted line of reflection. So if it's on the line of reflection, the image is just going to be itself because it's on the line. If point B is not on line M, and this is going to be super important, M is the perpendicular bisector of segment B, B prime. So what that means is, for example, B, B prime, notice how if I take point B, I can reflect it by drawing a perpendicular line to the line of reflection, and then I draw another perpendicular line the exact same size in the opposite direction. So when we're reflecting, our pre-image is the same distance from the line as our image is. But we would do that by drawing perpendicular lines. So that's how we're going to do this. When we're reflecting over vertical and horizontal lines, that's not as difficult to do, but when we reflect over a diagonal line, we're going to have to make sure we draw perpendicular. So for today, you probably are going to need something with a straight edge, and ID cards work perfectly. So if you have your ID card, you're going to use it in just a few minutes, okay? A reflection is a rigid motion, so reflections preserve distance and angle measure. Okay. reflections map each point of the pre-image to one and only one corresponding point of the image. So just like what we did with translations, if I'm reflecting something, the size and shape remains exactly the same. So would my image be congruent to my pre-image? Yeah, because it's the exact same shape. It just reflects over a line. When it says it maps to one and only one, that means that point B maps only to point B prime. C maps only to C prime, so it doesn't go anywhere else. Okay. There is a function notation for reflections. It's capital R. In the subscript, it's going to be what your line of reflection is. So in the example right here, it's the line y equals x. But sometimes it might just say x-axis. Sometimes it might say y equals 1. So it's going to be your line of reflection. And then of the shape. So in this case, triangle ABC. And we're going to do examples. So how do we do this? First step is we are going to show the line of reflection as a dashed line, so we know where it is. Oops. Step 2, we are going to draw a line that is perpendicular to the line of reflection to each point. So just like we did in the very top part from B to B prime, we drew a perpendicular line. You're going to do that to each point. Step 3, you are going to locate the image of each point that is equidistant. Equa meaning equal, distant meaning distance. So we're going to draw our perpendicular so we know which direction we're going. And then we're going to count the spaces so that our image is the same distance from the line of reflection as our pre-image. And then step 4, we are going to draw the new figure. And label its points. Okay? So you're going to draw the new figure and label the points. It's really not too bad. So we're going to do, the first 3 examples are just reflecting points. So we're just going to do points, and then we'll actually get into reflecting some images. So let's do the first one together. In number 1, I give you these 3 points, P, T, and Q, and I'm going to ask you to do reflections on each of those. Let's do number 1. Number 1 has a capital R, which means we're reflecting across the x-axis. So what I want you guys to do right now is you are going to draw a dotted line or a dashed line across the x-axis. So we know that's our line of reflection. Yeah, I know on yours you won't mind. Just so you know. And which point are we reflecting? Q. So here's Q. The perpendicular line to Q is going to go this way. So you're going to draw the perpendicular. And we need to figure out how far to go. So really, all you are going to do is count. So along the perpendicular, we're going to count to our line of reflection. So from Q, we're going to go up 1, 2, 3, 4, 5, 6, 7. So we're going to count above the line of reflection how many spaces? 7. So 1, 2, 3, 4, 5, 6, 7. So we're going to put a point right here. Okay, And we're going to label that Q prime. It is not hard.
This would be a lot more complicated.
Yeah. And label it Q prime so we know that that's Q prime.
So what does it equal? 7?
It doesn't equal anything. We just label it. That's all we have to do. Sometimes you might get asked what the coordinates of the point are. So you would just go from 0, 0 and label the coordinates of the point, which in this case would be -1, 2. So -2, +7. Okay. So sometimes you might get asked to label the coordinates. It just kind of depends on what the question wants to know. Here's what I'm going to have you guys do. Let's draw the lines of reflection together. And then I'll have you actually reflect them on your own. So number 2 says R of x equals 1. So our line of reflection is at x equals 1. Is that a horizontal or a vertical line? Think about it. It's where all the x's are 1. Is there a y there at all? So can our line x equals 1 intersect the y-axis if there's no y's in the equation? No, so it's a, what type of line? Vertical. So it's actually a vertical line through the point 1. Okay. So you are going to reflect point P across that line, so it's actually going to go in the opposite direction, right? Let's do this one together. So we'll draw our perpendicular line. How many spaces from the line of reflection is point P?
3.
1, 2, 3. So from your line of reflection, right here, you're going to count 3 spaces. So 1, 2, 3. And you're going to label it P prime. So from 0, 0, what are the coordinates of P prime? 1, 2, 3, 4, 2. So the coordinates are 4, 2. Okay. And then we'll set up T, and then I'll have you guys do it on your own. The line of reflection is y equals -2. Is that horizontal or vertical? That one's horizontal. So -2 right here. So I want you to reflect point T across that line. Okay, guys, how many spaces is T away from the line of reflection? 1. So that means we're going to go up 1 from the line of reflection. So T prime is right there. And what were the coordinates of that? 6, -1? Good. So, number 4. We are reflecting triangle ABC across what line of reflection? The x-axis. So the x-axis is horizontal. Question, guys, why is the x-axis horizontal when we have an equation x equals, it's vertical? Any ideas? Do you know what the equation of the y-axis is? It's not even x equals anything. It's y equals 0. Think about it, right? If I'm on the x-axis, how many spaces up or down do I go? None. So the equation is y equals 0. So even though we say x-axis, the equation is actually y equals 0, which should go more with horizontal vertical lines, right? Okay. So just make sure you're paying attention to what you're doing. Let's do point A first. So from my line of reflection, basically what this is, guys, remember in preschool when you were learning about symmetry and you would paint half of the butterfly and then fold it in half, and when you opened it, it had the other side on the same? Or if you haven't done that or you've done something similar, okay, this is the exact same. The dotted line is where you fold the paper. And when we flip it over, that's the image of what we originally had on the original side. So this dotted line is like if I was to fold my paper over, the image should look exactly the same, okay? So when we're doing A, how many spaces from the line of reflection is A? Did anybody count it yet? 6? Okay, so we're going to go down 6, right? 1, 2, 3, 4, 5, 6. And then make sure you label it A prime. I highly recommend that you label as you go. Especially when we get into different types of transformations, like what we're going to do tomorrow, rotations, you need to label it as you go. Okay, let's do B. So from here, B is 1, 2, 3, 4 spaces. So I'm going to go down 1, 2, 3, 4 and label that B prime. And then C is 1. So I'm just going to go down 1 and label it C prime. So when I connect them, it should look as if I took my paper and folded it, right? And then that's the mirror image of what's there. Okay? Questions or concerns? Jen. On number 10, you have a line of reflection of y equals x. So let's think about what that line actually looks like. If I were to plug in 1 for x, according to this equation, what will y be? If I plugged in 1 for x. If x is 1 and y is equal to x, then y is also going to be 1. So that would be the point 1, 1, right? If I plug in 2 for x, what's y going to be? 2. If I plug in negative 1 for x, what's y going to be? Negative 1. So the line y equals x, if I plug in 0, what's 0? So the line y equals x is the diagonal line through the origin with a slope of 1. So it's going to look like, it should go from corner to corner, basically.
That's going to be hard to count, huh?
That is going to be harder to count. So let me show you how we're going to do it. I'm going to show you how we're going to do it. This is the one where it's really important to do the perpendiculars. So let's do point O first because it's the closest. The perpendicular is going to go straight through the middle of the boxes. So really, my perpendicular line is going to look like that. Pretend like that's straight. So to count, really, we're just going to count along the diagonals. Okay? So from O, how many diagonals do I take to get to the line of reflection? Just 1. So I'm just going to do 1 diagonal. Here, is it easier if I erase those? So from here, we're doing 1 diagonal to the line of reflection. So we're going to go 1 diagonal after it. So right there. O prime. Just wait. We're going to do the same thing for N. So that's 1, 2 diagonals, so 1, 2. So here's N prime. So I did 2 diagonals. And M is the exact same. Don't ignore the line that makes the triangle. That's not what we're looking at. We're looking at the coordinates. So the perpendicular line is still going to go through the diagonals. It's just more of them. So we have 1, 2, 3, 4, 5, 6. So you're going to do 6 diagonals. 1, 2, 3, 4, 5, 6. And that's M. So that's the only thing I want you guys to make sure you are being aware of. Don't let the lines that are forming the triangle throw you off. You are just looking at the points. So your triangle, let's hope this is straight. Oops. Should look like that.
Yep. That looks beautiful.
Okay? So that's across the line y equals x. So do the rectangle for me. And the image is going to look I mean, it's hard for these, but just do each individual point and make sure you're labeling as you go.